Okay, I don't think that's working. Sully mentioned about this units conversion page. I'll print this for you to use on the test, and I'll leave these in there. Just some common metric to metric conversions. But you could build all of these down here in table 1.3 out of table 1.2. But I'll kind of botched that last Thursday and I want to move on. These are the English to metric ones. Just got this little box in there to highlight. And we'll get to temperature conversions. I'll give you that on the test as well. So it's just a matter of looking at this and picking out the right formula for a temperature conversion. Maybe we'll get to those today, but let's go to this. I haven't uploaded it yet, but this is just that page that says practice for test 1. I've added these. These are from that PowerPoint. Those are in your book. I just pulled them out of your book and put them in that PowerPoint. All right, so I'm going to add a little to this. Problems on density I have to add, and temperature conversions. So I'll go over this, and I'll go over some of the scientific notation stuff too. But did you guys read this? Did it help? I hope it helped draw some ideas together. I'll go through it, and maybe me going through it will. But virtually every number we have, like the 875 on the left there, I call that the numerical value. And then what's just to the right of that is units, that's milligrams. And it's generally helpful to have a label there that tell you what 875 milligrams of what? Well, potassium in this case. Sometimes it's a little weird using a label. Sometimes it's not even needed, but I always try to put one in just to stay consistent. I want to do this in terms of, let me get to the problems. If you had this problem, look at the problem in the white band up there and see if you agree with me that this is the case. 60.6 to, what is it asking for? If instead of A being phrased the way it is, it could have just asked that. It's the exact same problem. You see that? So most of these problems give you a little bit of context. I don't want to say the context is a red herring. It's a perfectly natural way to write a problem, but they're almost always just getting you to convert one thing to another thing. There are some that are a little more involved than that, but this one is just convert 60.6 kilograms to pounds. The other one is convert 67 inches to, B says convert 67 inches to 7. See what I'm saying? The context is there, but don't get lost in the context. These are almost always very straightforward conversion problems. So if you're looking at this, the next step, if you do these in steps, there's a certain place that significant figures show up, there's a certain place that scientific notation might show up. So let me go through this. I've kind of outlined here, and if you read this, hopefully you understand it, but, and hopefully I don't have any mistakes, but if you're reading this problem, usually the first thing on the far left, at least the way I do it, I would put and this is blood, no patient's weight. I have the label there. And I put that over 1 in there because I did it kind of neat in a spreadsheet. I had the 1 under this numerical value, but I do it over 1 like that. This number, nearly every one of these problems, it's the completely arbitrary number that some person made up to create this problem. This is a completely arbitrary number, 60.6. If you can recognize that number in the problem, you just put it here first, and that gets you started. And what you think next is, I've got kilograms here. The very next thing you want to do is put an equal sign and look at what you're asked for. In A, you're being asked for pounds. So I would just go ahead and put pounds here. And I guess you would go patient's weight. You could go ahead and put patient's weight. Where's the equal sign? Yeah, that's pound equals, okay, so you're coming up with some numerical value. But you know this much already, just before you work out any more of this or any calculation. You know you're looking for pounds, and the label is patient's weight in pounds. So the next thing you want to do, I do want to slide that down some. Pounds. Patient's weight, equal sign, there's going to be a numerical value here when I'm done. You might want to leave yourself enough room to put more than 1 term here. This, we're only going to need 1 more. But the next thing you want to do is go kilograms to make sure that cancels. Canceling, if you're new to this, canceling is just like if you had, if you were in an algebra class and you had 16 ABC squared over 4AC, and you were told to reduce that. C squared is just like C times C, so I could do this. And notice it's 16 times this, times this, times this, times this. 4 times this, times this. And the first thing you would do is, you could do it like this. Times 4 is 8. 2 times, so 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16. So this is like 2 times 2 times 2 times 2, and 4 is like 2 times 2. So I could expand it out to 2, 2, 2, 2, A, B, C, C. 2 times 2 is 4, AC. All of these are just multiplication. 2 times 2 times 2 times 2 times A times B times C times C. If you wanted to reduce it, you could just go cancel some 2's. What else can I cancel? I can cancel A's and a C, and what do I have left? 2 times 2 is 4. We got B, C. Oh, I just one. So when I say cancel units, it works just like this, where if you cancel the letters or if you cancel 2's. So the kilograms canceled, and I'm thinking, how can I get to pounds here? But you recognize that pounds and kilograms are both mass or weight. From there, you'll have this on the test, so use it. Go here. And since that's English to metric, you want to look in here. English units to metric units, that's metric. And I'm trying to get to pounds, which is English. And you look in here, that's why I got this little box. The masses are right here. So somewhere in there should be what you're looking for. Right here, 2.20 pounds is 1 kilogram. Is 1 kilogram. And I mentioned this in the thing, we're still talking about patient's weight. So I would put the labels there too. 2.20 pounds of anything is 1 kilogram. That includes this patient's weight, so 2.2 pounds of this patient's weight is the same as 1 kilogram of this patient's weight. So you add the labels is the most proper way to do this. And when you cancel, like I was just showing the cancellations here, really these two things are tied together. If I had kilograms of patient A and kilograms of patient B, and I was putting them together in one big calculation, I would need to differentiate between patient A and patient B. But what cancels here is the kilograms and the label, kilograms and the label, and that leaves us pounds of patient's weight. And I really like doing this just for the explanation, but in some sense, we've got, if I were being really proper, I'll put the multiplication symbol there, but usually in math, if you just put two things next to each other, it means this times this. And I mentioned before to you guys that if I drew a line like that, you recognize it as sometimes teachers will do it this way. They just call it the cancellation method, or dimensional analysis, or I've heard this called the train tracks method just because it kind of looks like train tracks. I won't generally write that, it's just an extra thing to write. But I think it's worth noticing that what this says is 60.6 times this times 2.20 times this. That's really what we've got here. And I could connect those and it doesn't change anything. If I said all of this is the numerator, all of this is the denominator, it really doesn't change anything. The calculation will come out the same. It's useful to do this because these things by themselves are a conversion factor, a mass conversion factor, English to metric. And this by itself is just from this problem. So it's helpful to have them separate. But what I like to do is rearrange these terms. You probably know this from algebra, but A times B times C equals whatever it does, I'll just say D. It's still going to equal D even if I rearrange these. C times B times A, distributive property or something like that. The order. So I can take this 60.6, erase it here and write it right here, and everything's still going to come out the same. I could jumble these up on the top out however I want, and it's still going to calculate out the same. So what I'm doing when I do this is just rearranging. I like to rearrange it where I have the numerical values. So from here, I got this numerical value. From here, I've got this numerical value. And on the bottom, I have some ones. I usually write them in, even though you're not really going to put them into your calculator and do anything with them. So I've got the numerical values together, and then I get the units. And that's kind of what I do here. Kind of what I'm doing here. This. Oh, I should have the labels. Should have brought the labels. Patient's weight. Okay. So now these can cancel. So this you just do by looking at it and cancel everything you can, and then whatever's left, you bring that out on the other side. But we already knew what we were looking for, so that's like a double check. It should be what you came up with to put over here to begin with. And this you do in your calculator. I didn't do my calculator says on there, but if I just literally go $60.6 times 2.20 divided by 1, but I'm not going to do that. My calculator says for this, so this you solve just by inspection and canceling. This you solve with your calculator. And I always encourage you to just go ahead and write down everything your calculator says. And once you put this in your calculator and calculate it out, now you think significant figures. You go back here, or maybe you can just look here, but When you do metric to English, there's a 1, always a 1. That's exact. That means it's infinite significant figures. It means you don't have to consider it for significant figures. And then there's one that isn't a 1, and that one you do include significant figures. That arbitrary number, it's almost always some number of significant figures that you have to consider. In lab, you're the one making a measurement. It's obvious that there's a certain number of significant figures. But that arbitrary number, it's pretty much always, you have to consider it for significant figures. This little magical one that I do just to make this sit on top, that's always exact, is what we call it. So you don't have to consider it for significant figures. So you're looking at 3 significant figures, 3 significant figures here. This is all multiplication division. Multiplication division rule says you look at all your input values, and the one with the least number of significant figures, that's what your answer has to be. Here we're tied at 3, and I like to point out, yeah, you can ignore these for significant figures, but truthfully, you're following the multiplication division rule. This is infinite number of significant figures, and this is only 3. So of course, this is less than this one. These are infinite significant figures, and this is only 3. So 3 is the smallest number. So then you look down here, and I encourage you to just literally underline the first 3. And then you go, I'm going to look one more out beyond there and decide whether I'm rounding that last digit. The 3 doesn't round this 3, so you end up with 133 as your answer. You don't have to think about the decimal or not, because there's no zeros here. It's when there's zeros here that you have to think about that, whether you put the decimal in there. I could put the decimal or not here, and it's perfectly fine. So my numerical value, and that's it. That's 100% correct answer. What I don't have on here, because the question doesn't ask it, but if it said down here at the bottom, usually it's the very last thing it mentions. It'll say, put your answer in standard scientific notation. If that's not asked for, then that's perfectly fine. That's 100% correct. If you're not asked for standard scientific notation, that's 100% correct. If you are asked for scientific notation, so you think about significant figures once you get here and you calculate an answer and you write down all the digits your calculator gives you. That's when you look back up here and go, okay, what's exact? How many significant figures? And then you apply it here. At the very end, when you go, okay, I'm done, 100% correct answer, then you make sure you look and see, did they want this in scientific notation? That's the very last consideration. Do I need to turn my answer written in the standard way into scientific notation? If you wanted to do this in scientific notation, you do look first and think, how many significant figures do I have? That's 3. When you're done turning it into times 10 to the whatever, you need 3 significant figures showing here, which is already there. But what I'm saying is you need 1.3. Notice that is completely equal to that. That's why I always point at the scale. That's numerically correct. It's 100% correct. Nobody can say that's wrong. But there's this convention that they sometimes throw at you. Oh, put this number in scientific notation. And then you would do this. I did that weird little algebra thing. I don't know if it helps or not, but scientific notation, you can do, I've got that. I need to move the decimal back 2 places. So I'm going to go times 10 to the negative 2. That'll move the decimal. So standard scientific notation means the decimal has to be just to the right of the first digit. That's what standard scientific notation means. So I'll look, how am I going to get the decimal here? Well, technically the decimal's there, 10 to the negative 2, but now I've changed the value of this. And I don't want to change the value of it. This is 100% wrong now. The answer was 133, not 1.33. That's 100% wrong now. To fix it, add times 10 to the 2, that's like multiplying by 1. That's like multiplying by 10 to the 0, which equals 1. And And then I'm just gonna take that and apply this in here, and this is left over. Maybe that little bit of algebra helps you, maybe it doesn't. Otherwise, you're kind of thinking backwards. You're going, to get to standard scientific notation, I gotta move this back twice, and that's 10 to the negative 2, but then you have to double think and go, but I need to write it as 10 to the 2. And that's where a lot of students mess up. You get the sign wrong. So just to emphasize, you're kind of doing it like this in your head. So that would be scientific notation for this. If you were asked for standard scientific notation, is that. And like I said the other day, if someone says put it in scientific notation, go ahead and do standard scientific notation. And just to remind you of that discussion, I love to call the books out on this, but that's the same thing as writing 133. Negative. All of these, and I could go on, I could do 10 to the 1, 10 to the 2, 10 to the 3, and I could move the decimal again and go 10 to the 4, and I could keep going infinitely. All of those are scientific notation. This one is standard scientific notation. The decimal just to the right of the first digit. So technically, if something says, write your answer in scientific notation, and you did this, you're still 100% correct. But go ahead and assume they meant standard scientific notation, because that's left off a lot. Did this book do that or not? Did I catch this book out? I can't remember. Well, whatever. Scientific notation means standard scientific notation. I think I did call this book out. That's why I got so excited the other day and made everything sound confusing. Okay, this is just going English to metric, inches to centimeters. You can find that one. You can find this conversion factor on that page. 2.54 centimeters equals 1 inch on that Word file. And find length. Yeah, it's there. Okay, this conversion factor is not on that page, but it's given to you. 15 milliliters equals 1 tablespoon. So going back to how you begin, when you walk up to a problem and solve it, there are 15 milliliters in 1 tablespoon. So you could go ahead and write as a conversion factor that you're going to use. And you're either going to use it like this, or it's going to be 1 tablespoon on top and 15 milliliters on the bottom. You're going to use it one way or the other in your actual math. But that's literally what this means when they put the equal sign. They're really making a relation. I think technically we're supposed to put 3 like that when it's a relation. No, it's a conversion factor for volume. How many milliliters are contained in 3 parts? There's the completely random thing that someone made up, completely arbitrary. Notice there's nothing arbitrary about 15 milliliters in 1 tablespoon. That's true today, it was true yesterday, it'll be true 10 years from now. If you're going to do a conversion between milliliters and tablespoons, that's written in stone. That's not arbitrary. The arbitrary number here is 3.5 tablespoons. So you would start by going over 1, and I've left room for later. Liquid medication, I just called it med here. Medicine, whatever that medicine is. 3.5 tablespoons of that medicine. Tablespoons needs to be on bottom, so this is the one I'm gonna use. And I'm gonna add med as the label. So tablespoons needs to be on the bottom. Tablespoon. And yes, tablespoon of that medicine. Is that it? Oh, 4 times a day for 1 week. Did I do that wrong? I did. No, A. So I solved A here. Did I solve B? Okay. So A is saying, that's the sum total of what you're being asked to do in A. Does that make sense? Throw some context in there, don't get lost. It could also say, and that would be perfectly equivalent. It'd be the same solution. See what I'm saying? English to metric, the one is exact, this one is exact, exact, exact. This is actually 2 significant figures. I doubt 1 tablespoon is exactly 15 milliliters. I bet it's 15.16144326. It's not exact. But they've just given it to us to 2 significant figures here. You might look up one day, say on the web, how many pounds to a kilogram, and it'll say 2.2. Then you've got 2 significant figures. And it's probably 2.20456321. They've just stopped at 3 there and given it in 3. Two significant figures, 2 significant figures. I'll just finish it out. 3.5 times 15 ends up being, well, I'll do it in my calculator. But just thinking wise, numerical value, and then a 1 and a 1. That you're going to do in your calculator. And right after you do that, you're going to consider significant figures. You've got tablespoons of medicine, milliliters of medicine, over tablespoons of medicine. These cancel. We already knew, though, just from reading here, that we need to end in some number of milliliters of medicine. So yeah, this is kind of a double check, because you could have known that right from the beginning. So canceling stuff down to what's left is really like a double check to make sure you're doing things correctly. For really complicated things, sometimes you'll catch yourself out there and go, oh, wait a minute, something's wrong up here because these aren't canceling to what I need. So that works as a double check. Does your calculator give you that in 2 significant figures? Sometimes the calculator lands on the right number of significant figures. Okay, good. My calculator says 52.5. So now that I've gotten my numbers out of the calculator, I look back and I go 2 significant figures, 2 significant figures, exact. So I need these 2, the 5 rounds the 2 up. So the answer is 53. Now you make sure you're not asked for standard scientific notation. If you are, your answer is going to be. I think you could leave it as times 10, but I think we always put a 1 there. And you bring down your units and label. So there's the correct answer in scientific notation. Notice you literally see 2 significant figures in scientific notation. I want to do B here. There's more than one way to do this, but you can overcomplicate it. Did I do B? The spreadsheet I gave you, didn't I put an answer to B on it? Did I? I swear I did. Did I? All right, so I'll do B before your eyes. The most sort of complete way to do this with units and labels. How many milliliters? You calculated the milliliters in A, and you could just use if you wanted to, but you can do the whole thing from scratch. You could do it 3.5 tablespoons of this medicine, and then go, I've got to get from tablespoons to milliliters. 15, 1 tablespoon of medicine. How many milliliters? See, my answer is still